Hi ladies, in this video we're going to go over sine and cosine graphs. So we have touched on very briefly what a sine graph is and what a cosine graph is, but you need to be aware that they're not always as simple as what you've seen. So kind of like parabolas, you've got y equals x squared, and that parabola can be shifted up, down, left, right. It can be made wider or narrower. And the same applies with your sine and cosine graphs. So we're not going to touch on transformations too much in this video. We're just going to focus on two things, and they are the period and the amplitude. So what I've got in this little theory box here, and this was taken from a methods textbook, so it looks a little bit different to what you might see in the year 10 textbook. But here are our two equations. We've got y equals a sine nt and y equals a cos nt. So basically, they're just your basic sine and cosine graphs, but now we've got an a and an n. The t, if you're thinking, oh my God, what does a t refer to? That's basically your x-axis, but they're just referring to it as the t-axis. So if we've got a graph here, this is t and this is y. Now, your basic sine graph looks something like this, which we know it goes from -1 up to 1, and it completes one full cycle in 2 pi radian, or 360 degrees. Now, I'm going to continue working in radian from this point forward because in methods, you'll just be working in radian. So just make sure, most of the time you'll be working in radian, but also sometimes in degrees. It just depends on what the question is asking. Now, there's a lot of theory here that we don't really need to go through just yet. I just want to tell you that the important things that we need to know right now are the a and the n. Okay, so that's what we're going to focus on in this general equation. What it says here is we've got a dilation factor. Okay, so dilation just means whether we're going wider or narrower. Okay, so the graph's not actually shifting left, right, up or down. It's just being made wider, or it's kind of like stretching it. So if you think of these as wavelengths, they're just being either stretched along the x-axis or along the y-axis. But we'll have a look at a few graphs in a sec. This point here, don't worry too much about this. It's just thinking about the coordinates of the graph, but we're just focusing on the period and the amplitude for now. So your period is calculated by doing 2 pi on n. So basically, we just want the coefficient of t. Okay, so whatever that is, we just substitute it in for n. Now, remember, the period is just the degrees or radians to complete one cycle. Oops. So in this blue graph that we did before, this was y equals, and I'm just going to use t, sine t. So the coefficient of t is 1 in this case. So 2 pi over 1 gives you 2 pi. So we can see that's why it's 2 pi. Now, we can have another graph, and I'm going to try to draw this as well as I can. Okay, so there's another cycle, and that's finishing at pi. Okay, so we know that halfway of that blue sine graph is pi, and this pink graph, I've just drawn it to pi. So that graph there is going to be y equals sine of 2t. So when you think of the coefficient of t, in this case is 2, when we substitute it into our period formula, 2 pi on n, 2 pi on 2 is just pi. So the period of that pink graph is pi. Your amplitude is basically your minimum and your maximum value. I'm going to just have to pause because my computer is about to die. I need to plug it in. All right, so where was I? The amplitude is your maximum or your minimum. So you can see here with both the blue and the pink graph, they're both going from -1 to 1 because the coefficient of sine is 1. Now, if I was to change that to something else, let me do a different color. There's a green. I feel like doing something in green. So let's do y equals 2 sine of t. Your graph is the same shape as the blue one. The only difference is, and I'm going to have to draw over my notes, yeah, it goes up to 2 and down to -2. So you still have the same peaks, and sometimes it's easier to do this, and it still goes through pi, but it just still starts at 0. It just goes all the way up and then comes back down and then goes back up. So it still has its turning point, I guess, at 90 degrees, which is pi on 2. It still crosses at pi, so it still follows kind of the same pattern as the blue one. It's just stretched, okay? So that's why we're talking about the dilation. So for A, so for the green graph, the value of A is 2. So you'd say it's got a dilation factor 2 from the t-axis. Okay, so your amplitude, but we're not talking about transformations right now. We're just focusing on the period and the amplitude. So as long as you can identify A and N in your sine and cosine graph, you'll be able to identify your period and your amplitude. Now, the next 2 dot points I'll just quickly touch on. The maximal domain is R. So R just means your restriction on your t values or your x values. So you can, your sine graphs can go on forever. My domain here, what I've drawn is from 0 to 2 pi for the blue and the green graph, and from 0 to pi for the pink graph. But my pink graph, I could also have a domain of 2 pi if oh gosh, wrong pink, sorry. Let's get rid of that. Oh, I didn't mean to do that. I just want to get rid of the pink one. Okay. Oh, it's getting rid of everything except for the pink. Okay, let's try the pink again. Okay, so it can go up like that. Okay, so now the domain is 2 pi. Okay, it's just whatever values are on your t-axis or your x-axis. Your horizontal axis, I probably should say. And your range is just the y values. So it goes from -A to A. So A being your amplitude. So you saw before with my green graph, I went from -2 to 2. With this pink graph, it's from -1 to 1. And we use square brackets to show that those values are included. If we had things that weren't included, we'd have a curved bracket. But the domain and range you'll see kind of here, but you'll cover in a bit more detail next year. All right, so question 1, we're going to state the period and the amplitude for all of these. So what I'm going to do first is just highlight the coefficients. So actually I might do the period in yellow, and I've just done the amplitude here in yellow, so I'll rub that out. All right, so we'll do the period in yellow and the amplitude in a different color. I'll just do the period first. Okay, so if there's no coefficient here, okay, it's 1. All right, so theta is your variable. Okay, so the period there, the period's not 1. The value of n is 1. The value of n in B is 2. Then we've got 3. This one here is going to be a half, and I'll explain that in a bit more detail in a sec. Okay, so I'm just highlighting the important parts here. So you're probably thinking, why are they using theta? Before it was t. It's the same thing. It's just another way of writing the horizontal variable or the x variable. All right, and then the amplitude is the number out the front. gosh, I feel like I'm doing an art project. All right, so let's write some answers. Okay, so for question A, your value of n is 1. Okay, so the coefficient of theta is 1. Remember, your period is equal to 2 pi on n. Whoops. So we've got 2 pi on 1. So that's going to be pi. And then your value of A is 3. So your amplitude is equal to 3. All right, let's have a look at question B. So this time our value of n is 2. So the period is equal to 2 pi on n, which is equal to 2 pi on 2, which is equal to pi. So your 2's cancel out. Your value of A is 5, so your amplitude is 5. All right, let's do a harder one. Let's skip C and do D. So our value of n is, now we've got theta on 2, so the coefficient is a half, okay, because we don't really have a 1 there. So your period is 2 pi and divided by a half. Now, if that's too hard to do, you can rewrite that as 2 pi divided by a half. Now, when you divide by a fraction, you keep your first number, so 2 pi, and multiply by the reciprocal of, what am I doing? Sorry, I got a little bit distracted. The reciprocal, so 1 over 2 becomes 2 over 1, or just 2. So your period is 4 pi. Your value of A, in this case, which one are we doing? 5. So your amplitude is 5. All right, now with the negatives, it doesn't make any difference to your amplitude. When you think about our parabolas, what happens when we do a negative? It flips them, okay? So the same will happen with your sine and your cosine graph. Okay, so the ones that I didn't do, you make sure you do them. You can either pause now and finish them or do them later. All right, so for question 2, I'll put this one down because it's a little bit harder. So, oops, I'm going to highlight the value of n. Okay, so you can see here, sometimes we've got t, sometimes we've got theta. Oh, and we've got x. Okay, so the variable's changed. So as long as you can identify n, you can do the period. So for the first one, n is equal to 2 pi. Your period is equal to 2 pi on n, 2 pi on 2 pi, which equals 1. All right, we might skip and do D because D looks a little bit tricky because we've got a fraction there. So 2D, our value of n is 2 pi on 3. So the period, same formula, I'm not going to write it again. So we've got 2 pi divided by 2 pi on 3. Now, writing it like that is not the best way. So let's separate it. It's the same as 2 pi divided by 2 pi on 3. And when you're dividing a number by a fraction, just like we did before, we keep the first number, change your division sign to a times, and flip or take the reciprocal of the second one. Now your 2 pi's cancel out and we're left with 3. Okay, so you can do the same thing for the other ones. All right, I'm just trying to think what the next question is. Oh, sketching. Okay, so before we move on to sketching, I just want to show you this little widget here. Now, this is a sine graph. It has got cos written on it. I don't know why, it's an error, but it's a sine graph. So this is talking about the dilation. Okay, so you can see we've got y equals 1 cos 1, it should be sine, sorry, equals 1 sine 1x. So it's a sine graph. So just imagine there's a sine instead of the cos. When I change the value of a, can you see that coefficient changing? So our graph is kind of getting stretched. The turning point and the point it crosses the x-axis stays the same, okay, but our amplitude is changing. Okay, kind of think of them as sound waves. So, you know, when you've got a higher pitch, you usually get something like that, and a lower pitch is lower. Okay, so that's your amplitude changing. So you've got your basic sine graph, and then when your amplitude gets bigger, there's your dilation from the x-axis, and you can also have below, and I don't have negative here, but if it was negative, it would go below the axis. All right, then you've got the period. So you can see there that the period's becoming bigger. Or not bigger, sorry, the value, I don't know why they've got k, because we're using n, but you can just see there how it's changing. Okay, so, and I just want to see what's down here. Okay, so that's your sine graph. Your cosine graph, exactly the same. So you can just see that's changing your amplitude and changing your period. Okay, so how they're dilated, but we're just talking about the amplitude and the period for now. Okay, so moving on to the last question. When we're sketching, it's a bit glitchy. Oops. Okay, so we're being given the graphs now, or the equations, and we have to sketch them. So I want you to use your calculator to check your answers, but let's do a few together. So I'll do A, and then I'll do a few others. So the first thing we need to do is work out the period and the amplitude. So do your amplitude first, which is quite easy, which is just 3. Your value of n, remember, isn't your period. It helps us work out the period. So n is 2, so your period is equal to 2 pi on 2. So those 2's cancel out. So your period is pi. So when we're graphing it, and I'm just going to do a rough sketch. Okay, so get your variables. We're using x and y. If it was using theta, you'd use theta here. If it was using t, you'd put t there. Okay, so our amplitude we can plot first. So it's going from, or up to 3 down to -3. When you're plotting a graph, okay, so our period is pi. Now your basic sine graph crosses the x-axis at halfway, so that's going to be pi on 2. And then it has its minimum, so your maximum and your minimum at a quarter of a way. So we're going to have pi on 4 and 3 pi on 4. So basically with your sine and cosine graphs, start with your period and then separate it into 4 equal parts is the easiest way to do it, because the shape is the same, except for when we move it left or right. Okay, so that comes a little bit harder, but we always start with a sine graph, start at 0. We have our maximum turning point at pi on 4. It crosses the x-axis at pi on 2. Then down here at 3 pi on 4, and then back at pi. So just sketching it. Oops, not the most accurate, although I think that's a pretty good graph. Okay, so your value, these 4 points will change depending on what your period is. All right, I'm just going to get the CAS calculator up to show you how to put it on your calculator. All right, so when graphing your sine and cosine graphs on your calculator, just put them in radian mode first. So you can always tell by up the top whether it's in degree or radian. So my calculator is currently in degree mode, so I'm going to change it to radian. And I like exact values when we're dealing with circular functions. Okay, so let's add a graph. So graphs. And our graph is 3 times, what's it, sine 2x. Okay, so there's our graph there. You can see on our axes, our x-axis, that it's in whole numbers. You can actually change that on your window if you like. So if we go to window settings, we're just going to pi. Actually, can I put pi in here? I don't think I can. I always thought I could. Whoops, didn't mean to do that. Sorry. Pi, yes. Okay, we just want 0, sorry. And then the maximum we'll have as pi. Your scale, now, whatever your period is, divide it by 4, so pi on 4, because that comes up with the important parts. And your amplitude, now we were going from -3 to 3. I'm going to do -4 to 4 just so we can see it. A bit easier. And we just want that to be 1. Okay, so there you can see 3 sine 2x. You can see the maximum value occurring over pi on 4. And it hasn't got all of them written on there, but the minimum value there is at 3 pi on 4. In the middle, we've got pi on 2. Okay, so there's your graph. Okay, exactly the same as the graph I drew. Let's do another one. I'm going to just scroll down and see if I can find one. Let's do G. I might just do 2 graphs. Actually, we'll see. I've chosen this one because it is a negative, so -3 cos pi on 2. Okay, so your amplitude is 3. Okay, and the negative is important, so we'll talk about that in a second. Your value of n is 1/2, so the period is equal to 2 pi on n. So 2 pi divided by 1/2, so times 2 is going to be 4 pi. All right, so let's get our axes ready. I'm just going to scroll so we've got a bit of space. Okay, so we've got theta, so I'm going to put theta here and maybe make that a bit longer. Y. And we're going up to 3, down to -3. Okay, so our period is 4 pi, so I'm going to put that down the end, and then I separate my axes into 4 equal parts. So 4 pi divided by pi is just, 4 pi divided by 4 is pi, so we're going up by pi each time, which kind of makes it a bit easy. 2 pi, 3 pi. Okay, so remember your basic cosine graph always started at 1, but because our amplitude is our amplitude is 3, we would usually start at 3, but that negative means we start at -3 because your cosine graph is reflected. Okay, so the negative means it's reflected now. So we go up. Okay, that was a terrible drawing. I had to start again, sorry. So let's draw our points. It's always easier. We cross at the first point. So in this case, it's pi. Our turning point here is at 2 pi. And then we come back and cross here, and we finish at 4 pi. Okay, so the cosine graph kind of follows the same pattern, but this one is just reflected, so it's kind of like upside down. And we go down to here. Okay, so let's put that into the calculator. So just change what I had. So it's now -3 cos, what was it? X on 2. Okay, and you're like, oh, I can't see it at the moment. That's because we've stopped at pi. So let's change our window. Okay, so this time I'm going to go up to 4 pi. My scale I'm going to do by pi, because remember that's what I drew. And my y min and max can stay the same because the amplitude is still 3. Okay, so there you can see the cosine graph. Let's maybe just do the next one. I'll do h, and then I'll stop the video because it's getting quite long. Okay. And I'm going to have to, what is it? Y equals 2 cos. Okay, so your amplitude is 2. The value of n is 4. So the period is equal to 2 pi on 4, which is equal to pi on 2. Okay, so let's draw our axes. So we're dealing with theta, our variable, and y. Our period is pi on 2. And sorry, I'm just thinking in my head. So we separate it into 4 parts. Okay, so if you can do a half divided by 4, then that's great. But if you think about halving pi on 2 is pi on 4. Half of pi on 4 is pi on 8. So we're basically going up by 1/8 each time. So 1/8, 2/8, 3/8. So 3 pi on 8. And then 4 pi on 8 will give you the pi on 2. Our amplitude is 2. So 2, -2. And it's a cosine graph, so let's put in our points. So it's not negative, so we'll start here up at 2. We cross here at pi on 8. Our turning point is at pi on 4. Then we cross here at 3 pi on 8. And then we go back up to pi on 2. So just joining the dots. And then there we go. All right, so let's quickly draw that on CAS. So I'm just going to, whoops, what are you doing to me? Change this. So 2 cos 4x, there it is. Now we need to think about our period. Our period was pi on 2, so let's change our window. What am I doing? So pi on 2. And the scale is pi on 8. Your y values you can change if you want to. Okay, and there it is. So when you're drawing, I'll just recap. First of all, figure out your amplitude and your period. Just always do one period. So this period is pi on 2, so that's your end point, and then divide it into 4 equal parts. So if it's a cosine graph, it looks like this, but your sine graph has to follow this shape. They do change when we translate the graph left or right. Okay, not so much up or down, but left and right will change your starting position, but at the moment we're not doing those sorts of transformations. All right, girls, bye.